Thank you. It's a great pleasure to be here. I want to talk about reactive programming. Best time to ask questions or make comments is when you have it. So please don't wait till the end. Anytime is a great time. Just draw my attention, speak up. I'll be more than delighted to hear what you have to say. So I'm going to talk about reactive programming, and let's talk about what it really is. So here's something I've learned over the past few decades. We work in a field where right about every 10 years, we'll give a new name for what we already do, excited about it. And this time around, it's reactive programming, microservices, and things like that. So nothing new, but we get excited. In the same way, reactive programming is really not new at all, and yet there's something exciting about it. In a way, if you really think about it, think of things like extreme programming. Well, extreme programming didn't really have anything new, and yet there was something new about it in that a greater emphasis on a certain concepts, certain practices. In a very similar way, reactive programming has really great emphasis on certain things we've been doing, but we should do more of it. And that's really what the emphasis behind reactive programming is. So it's a rehashed programming model, and that emphasizes on scalability and responsiveness predominantly. And of course, we live in a world where these things begin to matter a lot for the reasons why the world around us has changed. Well, if you really think about it, it has changed in the past about, I would say, 7 to 12 years, give or take. And one of them is that when you look at what's happened over the past 7 to 12 years, we have had a major shift from companies opening up their applications to their employees to companies making their applications available. And you have the change from going from employees to customers, it makes really a big difference. This is an example of reactiveness, as you can see right here, right? He's responding to events as you can, as change happens, so thank you. So the idea really is, when you have employees, your employees are usually captive users. Just whatever you give them. Customers are not like that. Secondly, there's way many more customers than employees. That changes too. There's a second thing that's happened over the past, give or take 7 to 15 years. That is the multi-core processors, the availability of the internet itself. And now everybody carries multiple devices with one of them. The biggest geek I know is my son, and he's a teenager. And the other day I patted him, and several devices fell off of him. I don't even know how many he has. I couldn't confiscate all of them. So now people are carrying multiple devices. We're talking about wearable devices. What that means is people are carrying watches around, and your watch is constantly talking to the internet. Now, can you imagine what's going to happen when people walk around with wearable devices? Not just watches, by the way. We're talking about people wearing earrings, tongue rings, nose rings, all of them internet-enabled. That will be a fascinating future we're going to live in. And when that happens, what's going to happen? We're going to be transmitting a lot of data, which means applications have to be really, really responsive. So responsiveness and scalability are extremely important. But let's talk about scalability for a minute. What does it really mean? Well, it doesn't mean you run things faster. It simply means that you're able to really support a boatload of users, a lot of users. And how do we really get to the point where we can support a lot of users? Well, let's think about it. Let's say you go to a website, right? And the website is taking a request, and then what do you see next? You're seeing the spinning wheel. It's taking time to respond. What does the user do? The user says, oh, poor website is taking time to respond. Let me help it, and presses the refresh button. What does it do? It sends another request to the website. Now there are 2 threads running for the same job rather than one, and the user says, let me help again. This doesn't really help at all, and it brings down the whole system even. And that's not the way to really achieve scalability per se. Well, that's one problem. The other problem really is, if you take a system and it's taking time to respond, what's going to happen? Let's say you walk into a store, and the minute you walk into a store, you see that the employee is very busy with another customer, and what do you normally do? You try to make eye contact. That didn't work out. You look at the floor, you look at the ceiling, you look at the wall, and you quietly walk away, because there was no response at all. But on the other hand, you walk into the store, and the minute you walk in, the customer looks at you and says, I'll be with you shortly. You probably waited for about 15 minutes. Why did you wait for that long? Because of the eye contact and said, I'll be with you. You are important. or not. So the point really is that when a system is responsive, we tend to stay with it, and a non-responsive system lose pretty quickly. So scalability and responsiveness are extremely important in the world we live in today. But how do we go about doing that? Well, that's exactly what we're going to talk about, which is what reactive systems are all about. Well, where did this concept of reactive programming really come from? Well, this actually was created, of all places, in Microsoft Research by Eric Meyer. So it's been around for quite a while within Microsoft. But you know one thing about Microsoft and technology related to Microsoft, those are really wonderful people. They'll create stuff and they'll quietly use it. Whereas that's not the way things are in Java and JavaScript. In the Java and JavaScript, the minute we find something, we won't use it. Instead, we'll spend the next 15 years creating frameworks and libraries, thousands of them. Well, so when people in the Java community and JavaScript community got hold of this, they said, well, this is awesome. We'll not use it. We'll create more libraries on it. So people got excited because of that. And of course, we're talking about it more and more. So there are quite a number of libraries for Java and JavaScript to do this. But a reactive system, so when he termed the word reactive, he called it reactive programming to the true sense of the word reactive. Well, unfortunately, the word reactive has a negative connotation in the... So you never go to an American, you are a very reactive person. You lost a friend if you ever said that. And the reason is a reactive person is a person who constantly complains and doesn't really do things proactively. Well, had they thought about this, they would have called it proactive programming and would have had twice the number of people in this room today. But they called it reactive programming. Well, reactive programming, to the true sense of the word reactive, is that it responds to events as they happen. So in terms of this, what does it really mean to us? Well, it's a system that responds to events as they happen. When obviously you want location transparency when it comes to applications for scalability reasons and to be able to really evolve the system. So you can have events to go or nothing new at all. It's been around for a long time, but event-driven programming is emphasized in reactive programming. You want to provide scalability. Now, why would you want to provide scalability? Well, I got a and I can ask them how many users they have on a given day. They'll tell me they got about 200 to 300 users. And you're like, gosh, really, 200 to 300 users? But on about 4 days in a month, they will have about 5 million users. Well, that's the type of the business they are in. There's a very high peak period, and then there's a period when nobody really cares about the system. How do you scale for something like that? Or what about a system where, let's say, for example, it's a system that monitors traffic, let's say. Peak hours, business hours when people are going to be going to work, and then there's a doldrum period, and then again there's a peak, and then the night period. But you cannot really predict it also because there could be an event, and then of course the peak load goes up at other times as well. How do you scale for such load when you don't have a real good prediction on the type of load you'll have constantly? Well, you need some way to really do this. Well, thankfully, we have a way to already do this. We call it elasticity. So elastic computing gives us the ability to scale properly as well. And so we can use elasticity on the cloud and so on. But what about responsiveness? I mentioned about responsiveness. We definitely want the systems to be very responsive. And so what is responsiveness? Responsiveness doesn't mean you have a response. It simply means that you respond, not an answer, but you get back a response saying, I'm still working on it, or you start giving partial results along the way. If you really think about it, the world quite adopted to the infinite scrolls, if you will. So you go to a website, remember the first day you saw infinite scroll? And you scroll down, and you're like, gosh, there's the data, and then you scroll, and you're like, hey, what's that? And then it immediately fills in, and you kind of got... But that's really a good advantage of having response faster rather than having all the results really available to you. But what about resilience, though? Well, if an application is not resilient, users don't like to use it. So, for example, each one of you have, maybe one or more smartphones or smart devices. If I ask you, how many applications do you have on your smart device? Well, I can tell you, I've got about 100 applications on my smart device. If I ask you how many of these applications you actually use, you're probably going to say you use about 4 or 5 applications. What about the other 95 applications? Why are you not using it? Well, because they're all pure crap, right? And you don't like them. In fact, you hate them so much, you don't even want to touch them to delete them. You just left them there to die, right? And that is what you do when applications are not really resilient. You don't like them and you just leave them alone. Resilience is very important. But there's one thing we got really, really wrong. We use the word exception. Well, then we say it's exception. They should have called it normal because it happens all the time. Why would you want to call it as an exception and then treat it like? So what do you normally do? You say, well, I'm going to be doing the happy path first, and then in the end I will make an exception, and that end seems to never come about. Well, I actually teach at the University of Houston remotely. I've been teaching there for about 25 years. And recently I was in a conference, and one of the attendees came to me and said, hey, Venkat, I took your class back in 1998. I said, oh boy, that's a long time ago. I'm surprised you still remember. He said, yes, but there's a reason I remember. I said, oh, that's interesting. What's the reason? He said, I took a class from you called Distributed Object Computing, and I was doing the final demo in the course, and right in the middle of the demo, you walked over, disconnected the Ethernet connection, went back and sat down and said, proceed, and I failed the project and failed the course. I said, oh my gosh, I'm really sorry to hear it. He said, no, don't apologize. I came to thank you for failing me in the course. I said, why would anybody thank somebody for failing in the course? He said, because that's the last day I ever wrote code without error handling. Because every day at office now, when I code, right in front of me on the wall, I have a picture of evil Venkat. And I look at the evil Venkat, I never ever forget to code, for error. I don't think everyone wants to have a picture of evil Venkat in front of them, but the point is we have to handle exceptions properly. That becomes extremely important for creating applications that are usable. So those are the 4 cornerstones of reactive programming. Scalability, of course, through elasticity, event-driven development through messaging, of course, resilience, and then, of course, responsiveness are key important things. And that's basically what reactive applications wants to make us think about. Well, okay, great. Now we decided we're going to do all of this, but how do we create a responsive, reactive, resilient application? Oh, this is easy. We could all use multi-threading. Well, imagine for a minute what happens when you create hundreds and hundreds and hundreds of threads. The first problem is the number of threads is equal to the amount of memory you have. So you cannot kind of scale in your own pace. That's a limitation. Second, you have a lot of threads running. That's great. But imagine now for a minute, one of those threads failed. How do you deal with that failure? Well, the thread pool thread says, I don't care about you. I'm going to save my own life. So it'll suppress the exception, throw it away, and walk over like nothing happened. Well, let's say you put a mechanism to really take the exception and pass it to the main thread. Hey, this is great. If one of the threads fails, I know what thread failed. But how is life normally? One thread is not going to fail. About 150 threads are going to fail at the same time. How do you deal with 150 threads failing? If you want a real-life equivalent of that, it's like running a daycare center and all the children start crying exactly at the same time. That's the way it feels like, right? How do we handle all this failure and you have no clue where to go from here on? Well, that becomes really a mess. Well, wouldn't it be nice to really propagate the error or the data back to the calling thread? Well, here's an idea. We could use futures. Well, if you ever used a future, think about what you did when you used a future. You call a thread, and the thread immediately gives you a future. It's like, hey, thanks, thread. That's a future. And what do? Turn around and call a get on it. That's no future at all, right? We're sitting there and waiting. Are you done yet? Are you done yet? That's not a good result. That's not a good use of resources. That doesn't work really well. Okay, here's a great idea. We could use a callback. If you think callback is a great idea, I've got a suggestion for you. When you go back to work, walk quietly near a JavaScript programmer and say the word callback and watch them begin to cry uncontrollably, right? Because JavaScript programmers know how terrible callbacks are. You will never be friends with them if you ever said callbacks are cool. So that doesn't go very well. It doesn't compose really well. Okay, life really sucks. What do we do? Well, let's think about this for a minute. Maybe what we want is really a change in the level of abstraction. Well, but isn't that what we do? If you really look back in time, we used to program in Fortran, okay, a long time ago, and we had integers and doubles. Then we said, hey, that's not enough. I'm going to have structures to program with. Well, that was interesting for a while, until we saw that everything becomes a mess, talking to global data, Then we said we'll have objects with encapsulation. Seems like a great idea. Another level of abstraction. Well, but that's not enough. We want collections of objects. Yay, that's great. But now we've been doing collections of objects for a while. But I want you to think a little bit more about what we've been doing as an industry for a good about 15 to 20 years. And I'm going to say pretty much almost everybody what we've been doing is called CRUD. Would you agree with that? Most of the applications are CRUD applications. But you want to really think about it. Does the entire world fit into a CRUD model? Maybe it's time for us to rethink about it and say, maybe we don't need to be doing CRUD for everything. Maybe there's something more than CRUD, not a create, read, update, delete all the time. Maybe there's something else we need to really do. And so in that regard, what we want to really think about is a different model, a different level of abstraction, but this is where data flow comes in. And I want to, of course, remind you, that's also not a new concept. Data flow has been around for a very long time. In fact, back in the 80s, people got excited about the so-called Manchester machine, which is really a machine created in Manchester University, and that was supposed to provide us a really nice data flow computing. That really didn't go anywhere, unfortunately, but the concept of data flow computing has lingered around quite a bit, and that's pretty phenomenal in terms of what it can do. Well, data flow simply says, as soon as the data becomes available, you're ready to fire an execution of the particular function. Well, if that is the case, we live in a world where data seems to become available quite constantly. For example, I like to listen to NPR, the National Public Radio, so I turn on the radio and I listen to the program, the broadcast, very nice. And then, of course, I say, I don't want to listen anymore, I got to go to work. I turn it off, but what happens when I turn it off? The radio station doesn't say, oh my gosh, Venkat turned off the radio, stop everything, right? No, they continue to broadcast it whether I listen or not. And I can either listen right now, or I can come back and listen to their program later in the evening through their streaming service. In other words, where does CRUD fit into this model? Well, it doesn't really make sense to use CRUD. It's a stream of data that's flowing through, and I'm interested in listening to it, so we can think of this so-called stream of data. Let's enter in this thought for a minute. Can you think of a few streams? Just blurt out. Don't worry about being right or wrong. What do you think is a stream? What around you is a stream of data? What? A voice, absolutely. Voice is a stream of data. Yes? What else can you think of? Mouse movement. It depends on how much coffee you had, right? So it can be really, really fast. Absolutely. What else that's a really good way to think about it. What else can we think of? Oh, monitoring data, absolutely. You're trying to monitor maybe a device, a control system, whatever you're trying to monitor, a stream of data. Anything else? The stock market. What else? What did I hear? Water. Well, that's a boring stream. That's too natural, right? We geeks sit in the office. We don't look outside. Yeah, but water stream, absolutely. What else can we think of? A television. Movies. What was it? Traffic. That never moves in where I am. Okay, yeah, stream of data. So a lot of these can be streams of data. Time itself could be a stream. Stock market, right? Twitter feed, all of these could be streams of data. Well, great. Now that we're talking about streams of data, how can we then work with the stream of data? That's what I want to talk about next. Let's start looking at some examples of this. So I want to take a little problem, and I want to work through it. But for this problem, I need one kind volunteer who has a smartphone and who can help me. Who wants to help me? Don't be shy. One person. Yes, sir. What's your name? Say that again. Stats. Very good. I got this little token for you. You're done. You can take it from me. This is not a stream. It's a CRUD. But I'll leave it here. Well, you don't have to come right now. You can sit there, but you can take it later. I promise you nobody else will take it. But are you ready for the challenge? Yes. All right, here we go. You have your smartphone ready with you. All right, he's all set. Great. I want you to tell me the stock price for these three stocks. Apple, Google, and Oracle. This is a HTTP. Okay, let's try again. I want you to tell me the stock price for those three stocks. Apple, Google, and Oracle. You got a smartphone. Look it up and tell me. Are you done? You're smiling at me. You're looking for it. You have the answer already? What, is it old data or new data? Huh? Look at him, though. He's still stuck on it. Do you have the answer for me? Well, thank you. You really did a good demonstration. We got to give him a clap. So what did he demonstrate? He demonstrated how the World Wide Web works, right? What does the World Wide Web say? 404, error. I couldn't read it. That's what he said first. I'm like, here's the data again. And then what did he do? He went off to compute it, right? In the meantime, I'm like, never mind, I don't want the data. Are you done? He doesn't even care to look for me, right? And after all the time, what is he going to do? I got that. It's like, where did the user go? And in all that time, what did he do? Completely waste performance, isn't it? That's not going to be scalable. But I asked this question a few weeks ago, and there was one guy who was absolutely brilliant. Nobody else has done this so far. When I gave the 3 stock symbols, the guy immediately said, oh, you want the 3 stock symbols? No worries. And immediately recruited 3 people around him and said, you get the price for Apple, you for Google, you for Oracle. He nicely demonstrated not only can you waste a server, you can waste a cluster of servers also, right? And this is amazing how you can work through this. Well, that's one of the problems today is we've been really not responsive at all. We feel that our job is to respond to users. How naive that is. We don't want to really respond to users who don't care to be around. And guess what? With mobile devices, fewer users care to be around. We live in a world of instant gratification. Do you have an answer for me now? No, I'm gone, right? So there's no point taking a user's request and running for a long time. You always have to take very small steps and see if it's still relevant. Could you please help me? We're still looking for the data. Okay, so the point really is we don't have to really, to go through that length to respond, we have to be really fast. So how are we going to do that? Well, the way we're going to do that is to become responsive, but this brings to what's called an observable, which is the first thing in reactive programming, is we have a data source, a stream, and so we have an observable on the stream. This is going to pour data towards us all the time. Well, how is it different from the iterator pattern? The iterator pattern, you normally pull the data. In the observable, it pushes the data to you. So that's one big difference between the two models. You're not sitting there and pulling the data. You subscribe and say, I'm done. Keep pushing the data to me when it's available, when it's ready. So you get the data pushed to you. This could be synchronous or asynchronous. You can vary this based on what you want. And of course, how is it different from the observer pattern? Well, observer pattern has been around for a very long time, but with a couple of different differences. The first is, it sends you the data as and when the data becomes available, it pushes the data, but it also can tell you when there is no more data to be sent towards you. So for example, let's say you're working with a stock market, well, there's no more stock data coming for the day. It can tell you there's no more data, go do whatever you have to do. So there's very clear delineation between a data stream and the end of the data stream. But it also contains an error channel to propagate error towards you so you can handle the error properly when the error does happen. And of course, it could be synchronous, asynchronous, could be lazy evaluation, all those benefits you get out of it as well. Well, it also can be encapsulated. You can vary the client implementation independent of how you want to vary the server implementation as well. This gives you quite a few benefits. Well, that's enough talking. Let's look at an example of how we can actually implement this. So I'm going to go back here and say, well, I've got a collection of symbols. So I'm going to say stock server. I'll call it as get feed right now. And I'm going to specify the symbols to it. Well, obviously, we need to use some kind of a library to do that. In the Java world, there are quite a number of libraries already available to do this. You can pick and choose anything you want to choose. Well, apparently, the guys working at Netflix had a problem. They had a streaming problem to deal with. So they decided to create a little tool and open source it, and that's called RxJava. The concepts I'm going to talk about here are pretty universal. You can use any library on any language you want to, but to do an implementation, we need to pick one. So I'm going to pick RxJava for that reason. So I'm going to go ahead and use RxJava. So in this case, I'm going to bring in the getFeed function, and I'm going to say observable of a stock info, and that's what I'm going to bring in to begin with. Well, obviously, we need to know what observable is. So I'm going to go ahead and bring in observable right here. And I'm going to say this is going to become our little observable to brought in. So this is going to be import, and it's going to be rx dot observable, and that's basically what I brought in right here. So that's our observable. I haven't written any code in here, but this is a lazy evaluation. So you go to the feed and say, hey, can you please get me the feed? It immediately gives you back an observable and says, here you go. I'm not going to do any work for you right now. I'm going to be pretty lazy about it. Now, why do we want to really do that? And the reason we want to do that is, if you really want to make your application efficient, you don't do that by running really fast, but you do it only on demand, and you can postpone doing stuff you don't have to otherwise do it. So in other words, both in life and in programming, it's really a good thing to be lazy. So you can be lazy about it and say, I'll do it later, I won't do it now. And that's very different from procrastination. Procrastination is when you haven't done what you should have done. Well, laziness is the last responsible moment. You wait until you no longer can wait and get it done. So that's a lot better. So in this case, of course, I've got the get feed. So what am I going to do with this? I'm going to go back here and store that as a feed. And of course, once I got a feed, nothing really happened on that other side. Now I can go to the feed and say, feed.subscribe, and I'm going to subscribe to this particular feed. So I could specify in here new action 1, for example, and I can output the stock info right here. So that code looks a little ugly, but we'll come back and fix it in a minute. But all I have done is I've subscribed to the feed and said, here you go, I want to be your subscriber. When the data is available, please notify me. And what am I going to do when the data comes? All I'm going to do is just print it out. That's all I'm doing. Well, we have to now go implement the other part of the application. So what am I going to do? I'm going to say observable.create over here. And the create function, well, you remember the good old pattern in effective Java, don't write a constructor, instead provide a static factory method. Well, that's kind of the pattern this was following. You call the create, and it's going to return an observable to you. So in this case, I'm going to say subscriber. So that subscriber that I'm going to get on my hand. And I'm going to say, in this case, I'm going to provide a little implementation, let's say while true, and I'm going to do some work with this particular observable to respond to whatever data that I'm receiving. So what am I going to do within this? Well, I can use a for loop, I can use a for each and all that, but I'm going to jump right ahead and use Java 8 in this case. So I'm going to say symbols.stream, and then I'm going to perform a for each of the symbols in the stream. I'm going to simply say subscriber, and well, before that, pardon me, before this, I'm going to say for each of the symbols, perform a map operation of stock info, and I'm going to call a fetch function. So the fetch function is going to go fetch the data from a remote service, and then give me the data right here. And all I'm going to do in this case is, in the for each, I'm going to say, well, subscriber, and on next. Well, in reality, you wouldn't be writing a loop like this. Instead, you would be the data source, and you would be generating the data as and when the data happens. Hey, what if I want to go across a remote service? You could use WebSocket if that makes sense. You could use a RESTful service if that makes sense. You could use a messaging architecture. You could use remoting like Aka's actors. Whatever that may make sense, you can do remoting through those mechanisms. Well, once I do, in this particular case, I'm going to just sleep for a little bit. Let's say sleep for a second. Well, of course, once I sleep for a second, I want to repeat this and go through and execute this particular process. All right, so let's go ahead and say this is going to be our thread.sleep for that milliseconds I'm interested in sleeping. Great. Now that we have done with that, let's go ahead and take a look at what this guy is going to do. So if I go back and run this little code, what it's going to do is to start up, make a request to the service, and it's going to bring back the data, and you can confirm if the data is actually correct. And you can see that it's about $662.20, which is what I heard a few minutes ago when you said the Google price. So that seems to be getting the data and sending us the data. Now, real quick, that's a lot of code we wrote on the client side, but nevertheless, we can minimize some effort right here as well using the same things as Java 8. So I can say system.out and then say print line over here. And that, of course, minimizes the ceremony in the code and the verbosity. You can see that that's doing the job as well. So we can get rid of some of that fluff around the code. But let's take a look at what we just did. All I did was, don't worry about the implementation inside this here. This could vary depending on the source of the data. But you subscribe to an observable, And what you got back here on the client side is an observable, and you subscribe to the observable, you sit back and relax. Whenever the data is available, it is calling you and pushing the data towards you. That's basically what you're seeing in here. So that's the very first step. You can sit there and listen to the data, receive the data when it arrives, rather than you having to pull the data repeatedly. So what does this provide for us? Earlier you mentioned about monitoring to control systems. Guess what's going to happen? You go to the control system and say, can I have an observable please? And it gives you an observable. You subscribe to your control system. You can sit there and be notified whenever the data becomes available through the control system. So things that you monitor, things that you are interested in observing, you can be notified by them rather than you having to really loop through and get the data repeatedly. Life becomes a lot easier for you to work with. So that's the first thing you saw, how that helps you to change the way you code. However, that's not all we want. We want to be really responsive. We want to be able to be resilient as well. How are some of those things going to work? Well, one of the problems we talked about a few minutes ago is when he nicely demonstrated going to the service and trying to get the data, we found a problem, right? He was so busy getting the data when he was emulating the current web services, he did not take note of the fact that I don't want the data anymore. So you want a two-way communication where while he is busy looking for the data, you want to be able to tell him, I don't want the data anymore. So there's got to be a two-way communication, or for him to come back and tell me, I don't have any data for you also. So how can we go about doing something like this? Well, let's take a look at one example where he can notify me that there is no more data. So notice in this case, I'm going to go back to this and say, well, let's just keep it extremely simple in here. I've got a little counter, and I'm going to say while count is less than 10, go ahead and do that, and I'm going to just increase the count at this point. And in this case, of course, I'm going to loop through 10 times through the loop. When I'm done with it, what I'm going to do at this point is I'm going to simply say subscriber.onCompleted. So that's a way for you to tell the subscriber, I don't have any more data for you. So what reactive streams do is they have a data port open for you, but the minute you say onCompleted, they block the data port. And if you ever call on next after that, none of those data will go through. So they give you a nice data channel which gets closed when there is no more data. And you have closed the terminal, you said onCompleted, and you're blocking it. You're not going to send any more data through the channel. That's a nice way for you to control what flows and when it flows. And you're going to control this pipeline after you're done with it. So you can indicate onCompleted. How can the client know that you don't have any more data? Well, the client can know that by implementing other interfaces here. So for example, I can say on subscriber, and I have on completed, as you can see. I'm going to say no more data, so you can see that I can receive a no more data signal when there is no more data. But when there is data, of course, you can come back here and see output, and I'm going to say stock info. I can start displaying it. So if you notice this time, we got data coming through, but at any point the service decides there is no more data, it can immediately tell you. For example, let's say you're monitoring a flight. Well, the flight has landed, and it's going to send you a little note to say, there's no more data, go home, do whatever you want to do. So you don't have to be blocked on that particular observable for a long time. It's going to communicate back to you saying, I don't have any more data for you, and you can respond to that based on that particular event. So in this case, of course, well, the network's a little slow here, so it's pulling in the data, but once it hits the 10 times, it's going to tell me there's no more data, and as a result, as a client, this particular function will get called, and I can know that there's no more data. I can do my cleanup operations or bookkeeping operations. Whatever I want to do, I can manage that at that particular point. Well, that's a great way for you to know when there is no more data coming in, and you can see that getting printed right in the bottom, no more data. Well, but what about you telling the service you don't want any more data? Well, let's think of an example where we would want to do something along those lines. Let's say the service is continuously sending data to you, and you are receiving to the data from the service, and this is going on. But there are times when, let's say I'm interested in performing a trade in the stock market. So I'm going to say, hey, I'm going to be monitoring this particular stock price for Google. I'm very interested in buying Google stock price, but it's way too much price for me to buy, but I want to wait until it hits a $600. Well, I've got a little subscriber. It keeps telling me what the price is as the price is changing, but the minute it hits 600, what do I want to do? I don't want to be notified anymore. I want to stop that and go do a trading. So there's got to be a way for me to say, thank you, but no thanks. Don't keep pushing data to me. I am done. So how do we do that? Well, you can actually do that from the client side. So notice what I'll do here. I'll go here. This is a silly example I'm going to use. And I'm going to say if stock info.value is greater than 600, I'm going to simply say in this case, well, how about this? No, thank you. I am done. And then, of course, I'm going to say unsubscribe. And you're able to unsubscribe from this and say, thank you, but don't keep sending any more data to me. Now notice when I run this, the client is receiving the data, but the minute the client receives the data once, it can tell the service, thank you, but don't do this anymore. And you know how this service is behaving? This service is behaving like some people in the office, you know who I'm talking about, right? You go to them, ask a question, I got this doubt here, and they start explaining, and you got it. You say, you know what, I got it. And they don't stop. You know what I'm talking about, right? And they keep on going. It's like, dude, I really got it. No, explain to you to make sure you understand it. That's kind of the way the service is, how rude. Okay, well, we can fix it. So let's go back to the service and say, hey, service, while the subscriber is not unsubscribed, then continue to do that, right? So in this case, what he would have done is, he would be looking for the stock, but he would be constantly looking to see if I'm still interested in it. And the minute I say, never mind, I'm going to move on for other things, he's not going to waste his resource anymore. He's going to bail out. And that can be really better for scalability reasons. How is this going to help with scalability? Well, the way it's going to help with scalability is, the minute you say, I don't want this, the service can now better use its resources rather than wasting the resource on a client, a subscriber, which no longer cares about these kinds of services. So that is one of the things you see here is a nice way to communicate back to the service to say, I don't want the data, please. And the service says, well, thanks for stopping by. I'm not going to send any more data. So this gives a nice two-way communication. Now you may argue, hey, what's the big deal about this? I could have done this coding all by myself. That is one of the biggest problems in what we do, right? Because the first time you look at something, you say, I do that. And what happens when you start on something like that? And the next thing you know is you have a bloated piece of code in front of you. And the code you write, you have to come and maintain it. So here's one thing I've learned over the years. The code I don't write has the fewest bugs in it, right? Absolutely unbeatable. And this is also what I believe is true experience. You find a young programmer who just graduated from school, and you catch him on the way to work and say, hey, what are you doing? Where are you going? And the person says, I'm going to work to write a lot of code. Take note of that. Go to the same person 15 years later. On the way to work, you say, hey, where are you going? And the person says, I'm going to work to remove a lot of code, right? So that is what is called experience, isn't it? You learn not to write code because you know the code you have in front of you is the mess you have to maintain. So the beauty of this is, I don't have to write this code. The library deals with it. I can simply use it. If I don't want it tomorrow, I can set it aside. I don't have to really worry about it. So that's what benefit you get. So my philosophy in life is, do not build what you can buy, but also I want to second that with saying, do not buy what you really don't need, right? That could be a problem as well. So, but if this is what you really need, the libraries can help you to do whatever you want to do, so that can be a very powerful way of using it. So we saw how to really use the communication back and forth between the client and the service. The client is able to tell the service is able to tell the client, so that's a nice two-way communication. Please. Right. So the question is, and let me know if I answer your question correctly. So the question is, how can you manage the state between the two? There are two ways you can manage the state. The first way you can manage the state is you kind of told him what kind of stream you are interested in. For example, in the case of Twitter, I could say, give me the mentions, whatever it is. I could give a little initial state, because remember, it's a stream, and it could be pouring the streams towards you. That's one way to do it. The other way to do it is, we haven't seen this here, but deep down there is a producer and consumer model. So what you do is, rather than getting a subscriber directly, what you can do here is you can instead create a producer and you return a handle to the producer. And what happens then is the client simply says, I want the next 10, I want the next 20. It can ask you for a specific burst of data as well, and the service will then push it whenever it becomes available. But that's the extent to which you can actually do. There is no other state you can send back and forth. And the reason for that is you have an initial state you're saying, I want all the stream to start. But once a stream starts, you can't control the stream at that point. You can always terminate the stream and reinitialize the state for a newer stream to follow after that. But there's no intermediate state exchange beyond the initial time and then the burst of data you can request for. It would be really nice to have a way to really push back a little bit of data, but the streams don't handle that right now. Yeah. So that's basically a two-way communication. But there is another problem, though. We want to be able to do synchronous communication or asynchronous as the need may be. So to understand this, let's go back to this code for a minute. Let's get rid of all of this for a second and simply say system.out, let's say print line. And now I'm going to simply run this code, and you can see that it's reporting this as the time goes on. Great. However, I'm going to go back here and say, did I get here? Well, notice I did not get there, and the reason, of course, is this is synchronous. So what that means is, the minute I subscribe, I am waiting and blocking on it to receive the subscription, and I'm not really getting down here at all. Well, that's the default behavior. But remember I mentioned earlier, you want to be able to be asynchronous and do other stuff and not be blocked on it. So how do we go about doing this? Well, typically what you do when you want asynchrony is you would create a pool of threads, and the minute you create a pool of threads, you got other problems on your hand to deal with. So they said, why don't we take care of this for you so you don't have to work really that hard? So what you do is you come into the chain right here, and then you say subscribe on, and you say schedulers dot, and you can pick the flavor you are interested in. The from is simply a flavor where you're saying, I want to schedule my execution in a pool of thread you provide for me. So if you already have a pool of thread, you can give me the pool of thread and it will run in that pool. Or you can say, run it in an IO thread. So if I run this code now, notice did I get here got printed right off the bat, and then of course it went through. You're not waiting on this anymore because that is completely asynchronous. And of course, if you're really interested in it, you would have to put other mechanisms to wait for the data, depending on whatever that could be. And you can then say, respond to me and tell me when this is being done. And you can take care of that as it may be appropriate. You can deal with that. So in this case, of course, you can see, did I get here got printed right there, but you can see the flow of data coming through. So that's a way for you to introduce a bit of an asynchrony and put it on a separate thread. Again, there are these configurations available, like an IO thread or a computation thread, for example, depending on what your processing needs are. If your processing need is a computation-intensive process, you could ask for a computation thread. If you're more of a IO and a blocking kind of a request, you can ask for an IO thread. There's also a few other combinations you could use as well. So you can start varying this on the client side. Similarly, you can vary the server side as well to provide asynchrony if that makes sense to provide. Well, given this, of course, what about errors? We certainly want to handle errors. We don't want to simply not handle, deal with errors, but you want to deal with this very proactively. But I want to talk a little bit about what are the different kinds of errors we can deal with. Well, the very first thing you want to deal with is that you could actually potentially lose a connection to a server, for example. You may have a network failure, for instance. You could have a partitioning of network. So there are so many ways things could actually fail. Now, one of the things is we need to really program defensively, so you always take every single step to cautiously deal with errors. Now, it is not about not failing. it is always about failing gracefully. So if somebody is trying to build a system that will never fail, they already failed in trying to even build a system. So failure is something we cannot avoid. That's just the nature. But what you want to do is, when a failure happens, you don't burn the building because of the failure. You gracefully recover from it. So what can we do to recover gracefully from the failures? Well, the very first thing is, at every level of the code, you handle exceptions properly. But we know already you cannot throw exceptions across boundaries so easily. You cannot throw exceptions across multi-threads so easily. Well, that's one problem. The other problem is the reactive programming concept nicely stems from the functional programming concept, where you have evaluation and function composition. Well, reactive programming builds on these concepts, the laziness and the composition of functions. But when it comes to exception handling, there is one thing fundamentally wrong with exception handling. Exception handling was created as part of imperative style of programming. Think about this for a minute. You are in a function, and what do? You call this function, and that calls this function, and that calls this function, and it blows up over here, and what do? You run back like a dog that was chased by a cat, right? And you're like, oh, I can't handle it. And then you run backward. Well, but that problem is, in a functional language, in a functional style of programming, there's no running back. You're in a pipeline. You are into the 7th stage. You don't say, I want my mommy, right? You don't run back. You got to be bold and move forward. So what do? Well, in functional programming, you don't throw exceptions. Instead, what you do is you propagate error moving forward, and you deal with it. So it's a very different thinking model. And when we come from the imperative style of programming, we get baffled with exception handling, and we say, oh my gosh, we can't handle exceptions. Well, no, you can, but you don't handle exception like the way you handle exception in the imperative style of programming. So in imperative, you go forward and you bounce back. In functional style, you go forward, and when something goes wrong, you continue to move forward, except that you kind of go in a different direction than you would otherwise when things have gone normally. So in that case, how do we deal with exceptions? Well, reactive programming says, I'm going to give you a data channel, but I'm also going to give you an error channel, so you got a little 2 channels to communicate. The data channel will give you the data as it arrives, and the error channel will give you the error whenever the error happens. And of course, one rule, the minute an error happens, the error channel gets the error, and the data channel is immediately closed. You don't get any more data. Now, why don't you get any more data? Well, imagine what you do when you write an application code. You call a service, and the service fails. What do you normally do? You're like, oh, I'm going to handle the exception. Oh, this failed. I'm going to call back right away. What does calling back on failure right away mean? The definition of that is called hope. Hope is a good thing. But the problem is, systems don't recover so quickly, right? If a system says I'm down, you don't go back and say, are you up now? Are you up now, right? That makes no sense, but yet that's what we do. This is like a multi-car pileup on the freeway, right? One guy hits the brake and 300 cars behind it backs up. It's like, why do we want to do that? So in other words, you want a really nice way to deal with errors, and there is concept of circuit breakers that we normally deal with. So what's a circuit breaker? Well, in your electrical system, what do? You plug a little power cord, and that goes fut, and you're like, oh wait, that actually messed up, let me fix it. The other scenario is you plug it, and the system says, oh, there's an overload, I'm going to increase the load over here, and that's a way to burn up the entire building. They did this about 200 years ago, and they figured this doesn't work. And then they started putting fuses everywhere, basically circuit breakers. Exactly the same concept in programming. So in programming, circuit breakers simply say, failed, I'm not going to send the request anymore through, I'm going to send you back an error. Well, you check back when it's appropriate, when the system is up. I'm not going to keep pinging on it down even worse. So you want to be very graceful when things go wrong. How do you propagate the error back to the caller? Well, that's exactly what we're going to do here. So if you look at this particular code right now, I've got this little while loop going through, but let's go to the fetch function for a minute. The fetch function is going and getting the data for the stock service, but at random time, I'm going to blow up with an exception. I'm going to say, oops, ran into trouble. Well, so this is going to fail at some random time, but what am I going to do? Well, I go back here to the code. I'm going to put a try block right here. And in this case, right here after the try block, I'm going to come back here to this and say, well, let's go ahead and catch the exception. So exception EX, and I'm going to catch the exception right off the bat. Well, great, I've got the exception handling. And what am I going to do now? I'm going to say subscriber.onError. I'm going to pass the exception details to it. But just to prove you the point, after I send the exception, I'm going to say subscriber.onNext over here and say, what about, in this particular case, I'm going to say, what about this? And I'm going to send a little bit of data to it at this particular point. Well, this is a stock info. Why don't we do this? Stock info, and I'm going to create one, what, and 0.0 and see what it does. So I'm going to get this through and pass it, just to prove you that it actually closes the data channel when an error has to happen. Well, now I go back to the code, and I'm going to go ahead and run the code and see what happens. When I run this, though, notice I'm not handling the error at this point. The data keeps flowing through. At some point, it's going to run into a problem, and it's going to throw the exception. Well, there you go. But what does the exception say here? Well, notice the exception says, on error, not implemented exception. So it's telling me, hey, you didn't open up your error channel. What's up with you? So in this case, I'm going to provide a system.out and provide a print line. All I'm going to do is print the error. So now that I've opened up the error channel, so that is the second thing that I'm going to go ahead and provide for that over here, so I can bring that into the picture. Let me go ahead and run this and see what this is going to provide for us. So I execute this. And in this case, of course, you can see the data is flowing through. And of course, as the data is flowing through, it's going to run into an error at some point. And of course, when the error does happen, it's going to send the error data back to us. And of course, that second parameter is going to report the error for us and say, hey, here you go, there's a problem, go deal with it. Well, that's the main idea. Well, obviously, in a demo, when you want the error, it doesn't happen. So let's go back and fix that. I'm going to just make it fail too quickly. So let's go ahead and say if it is more than 0.01%, and then we'll ask it to fail much more frequently. So in this case, of course, when I go back and run it, you can see that it failed. It said, oops, ran into trouble. And then, of course, it finished this up. But also notice in this case, it did not send back that particular data anymore because we closed the data channel when the error happens. So this gives us a way for us to communicate the error back to the client whenever something goes wrong. But there is one other problem, though. It is nice that it immediately terminates the data channel, but there are times when our needs are a little different. For example, let's say I'm writing a client where I need to go to a data source, and I'm interested in getting the data from this data source. But if there's a problem with the data source, I don't want to be suffering because of that. I want to switch over to another service. For example, let's say I'm interested in getting data about, flight information. Well, I go to a service, the service doesn't respond. I'm not going to say, sorry, I'm not going to pick up my family because I couldn't get the flight data, right? Well, it depends on family, but the point is that I'm going to really switch over to another service and say, I'm going to look for this other service because this one didn't respond, so you want to be able to switch to a backup service. Well, they thought about this quite a bit, and they said, well, we don't want to affect the service provider. We want to give the flexibility for the client to do this. So notice the beauty of this. I can go back here and say, well, in this case, I'm going to change this to let's say 0.5 to reasonably. Okay, now let's say in this case, how do I change this? I'm going to go back and say, well, on error, resume next over here, and I can provide a throwable. And in this case, I can specify, well, let's go ahead and print out the throwable. And once I print the throwable, I'm going to say return. Let's go ahead and say this is going to be a stock server dot. Let's say get feed on the symbols. And I'm returning a backup service when the main service actually fails. So if you notice over here, well, okay, they both failed. So the point really is that when a service fails, okay, let me increase that a little bit further. So in this case, of course, when the service fails, it will immediately switch over to another service at that point. All right, so this is the day when it wants to fail. Let's try this one more time. So in this case, of course, when the first service were to fail, all right, you get the point. So the point really is that it will, when the first service fails, it'll get to the second one automatically. And of course, you can configure this to keep going like this based on what your needs are. So the point really being, exception handling is something we got to handle very seriously, and error handling is important. And that is already baked into this for resilience purposes. That's provided for you also. Well, if you are interested in reading more about this, I highly recommend taking a look at the Reactive Manifesto, and that talks about a lot of stuff, how you can do things. I covered quite a few of those, but it's a good idea to read that to get a little bit more into the concepts. I did show you a practical approach of to how to do this. I didn't talk about elasticity much because you normally deploy it for elasticity. I didn't talk much about messaging. You can use messaging systems. I focused more on the observable and of course, the resilience part as well to a certain extent here. If you're interested in downloading the code examples you saw here, you're most welcome to download them from my website. So to summarize what we talked about, the main idea behind Reactive Manifesto is to provide scalability using elasticity, to provide event-driven development using messaging architectures, to be able to afford resilience so that applications will be graceful and they don't drain out your resources and the system doesn't come down crashing when things go wrong. And that is something they provide as well. And then finally, to make the application responsive. Now, there are certain applications where this makes a lot of sense to do. For example, I was listening to somebody the other day, and this company is already doing stuff where they are grabbing data live from people out in the field. As the people are working in the field, they are grabbing data, sending the data to the back office, processing it, and then the devices these people use in the field get updated with live data about what the reality of the condition where they are. So it's a pretty amazing world we live in. Imagine you have applications where you have wearable devices, where the devices can start measuring a couple of different things. Your body-related vitals, for example, temperature and various other things about you. Well, there could be health-related people who, depending on what it be. There's also cases where, as you are traveling around, imagine you are in the middle of a place like Des Moines, Iowa, or you are in Oklahoma City or nearby in Oklahoma, where it's unpredictable when the weather could turn into a tornado. People die because the weather changes very drastically. They never had an ability to know how the weather is going to be in the next 15 minutes. Imagine now you can have devices that constantly monitor the condition where you are and able to immediately signal you to go to safety. That can be extremely vital. I think we are in the cusp of the world where there are two things changing significantly. One is the world around us is changing drastically thanks to the availability of internet. Essentially, the ability to communicate is changing the world so very well. And with these smartphones and smart devices, we have the computing power on our hand to be able to compute and communicate with all these big data and frequent data. But there's one important missing link in there. You have the devices, you have the technology to communicate, but one thing you need is a better programming practices, which is what we are really excited about in the group here. And we are trying to really find a way to raise the level of abstraction. And I firmly believe that we are in the cusp of looking at a stream-based programming era. So maybe in the next 2-3 years, we would start programming more with streams than we've been programming with CRUD over time. And I think this is the birth of a very different programming model we are looking at. It's a very exciting time, and anytime we pick up something new, we're going to learn, we're going to make mistakes, we're going to learn from it. But I think this is a bright area where we are beginning to learn that we need to really do computing differently all over again. And I think that's really an exciting time to be in this field. There's a lot of things to learn, a lot of things to experiment, and a lot of things to build for the better as well. So definitely, and of course, the way that we can do better with this is to be very proactive about it and start learning about it. So it's pretty exciting times. I hope you found that useful. That's all I have. Thank you.